So here is a second example on implicit differentiation, and it is quite a bit more intricate than the first one, so we'll go a little bit more slowly through it. Okay, the first thing we see here that we have to differentiate is cosine. Okay, so the derivative of a cosine is always negative sine of whatever follows. Okay, so it's important to be patient here and to just follow the rules exactly as you've learned them. So when you differentiate a cosine, it becomes negative sine of whatever follows, which was negative sine of x squared y. But then you also have to multiply by the derivative of what's in here. So we're going to look now at the derivative of x squared y. Okay, derivative of x squared y. Okay, so u is equal to x squared and v is equal to y. This is product rule, of course. I didn't say that, but this is product rule because you have two variables multiplied together. U prime here will just be 2x, v prime will be dy dx. So that's going to give you x squared dy dx plus 2xy. Now, since there are two parts in this piece of the answer, when we bring it back over here, remember we're going to multiply it. We have to multiply it within parentheses. So it's negative sine x squared y times x squared dy dx plus 2xy. Okay, and maybe for clarity, we should indicate that this is going to be multiplied by the negative sine of x squared y. Otherwise, if we didn't have those orange parentheses around the negative sign, somebody might think, looking at this, that it was negative sine of just x squared y times x squared dy dx plus 2xy. But it's not. You have to find the sign first, and then the sign gets multiplied by what's in purple parentheses. Okay, the next bit is a little bit more straightforward. Negative 2y. Well, if you differentiate negative 2y, that's negative 2. The derivative of y is 1 dy dx. Okay, and that's going to be equals, and I'm running out of room here, x e to the y. Well, that again is another product rule. Okay, that's another product rule. Because there are two variables involved, x and y. So the derivative of x e to the y. And I'm just going to move this up here slightly so it's easier for me to read. I'll move it back after that. So u is equal to x, and v is equal to e to the power of y. U prime, derivative of x is just 1. V prime, okay, now, when you've got an e, when you differentiate an e, you get the same thing back again, so it's e to the y, and then you have to multiply by the derivative of the exponent. Well, the exponent is y, the derivative of y is dy dx. So this is going to be x times e to the y dy dx plus 1 e to the y, or just plus e to the y. Okay, so we'll bring that back in over here. So that's going to be x e to the y dy dx plus e to the y. Okay. Now you can see already that this is a little bit complicated. So what we're going to have to do here, we're going to have to distribute. Okay, so distribution, we're going to multiply everything in this parentheses by negative sine of x squared y. So let's go forward from here. So we're going to have multiply the first term. It's going to work out as negative x squared sine of x squared y dy dx, and then negative sign by this term is going to be minus, by plus is minus 2xy sine of x squared y minus 2 dy dx, and we're saying that that's going to be equal to x e to the y dy dx plus e to the y. Now this is probably a little bit more complicated than any function we've been used to looking at in the past, so you have to go slowly here and just take your time. Right. Next thing, anything with dy dx should all be on the left hand side of this equation, either the left or the right, but for simplicity we'll say on the left. So that'll be negative x squared sine x squared y dy dx minus 2 dy dx, and bring the next term across, minus x e to the y dy dx. And everything else needs to be on the other side of the equal sign. You have an e to the y over here, and this piece here didn't have a dy dx. So we'll make that plus 2xy sine x squared y. Okay, so let's factor out the dy dx here. If you want to, you can factor out minus dy dx. That might make things a little bit more neat, but it's not necessary, so I won't do it this time. I'll just factor dy dx out, and that will give me negative x squared sine of x squared y minus 2 minus x e to the y is equal to e to the y. We're not doing anything over here because this line was just about factoring out dy dx. Okay, and then we divide by whatever is attached to the dy dx to give us our final answer. So dy dx is equal to e to the y plus 2xy sine of x squared y divided by negative x squared sine of x squared y. Oops. Sine of x squared y minus 2 minus x e to the y. And that's it. And please, whatever you do, please promise me you won't cancel. Okay? Don't cancel. Cancel. There. Okay. It takes a long time, and it takes a lot of care and precision and accuracy. But if you are willing to buy into all of those things, then this is a problem you should be able to do. Okay, thank you.